Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Welcome to Lesson 16, Slicing a Right Rectangular Prism with a Plane. Classwork Example 1. Consider a ball, B. Figure 3 shows one possible slice of B. So here is a rectangular, two-dimensional space that is cutting through this ball and forming a circle cutout. So it says, what figure does this slicing plane form? And it is a circle. Students may choose their method of representation of the slice. Example, drawing a 2D sketch, a 3D sketch, or describing the slice in words. Okay, part B says, will all slices that pass through B be the same size? Explain your reasoning. So the answer is no. Different slices can result in circles of different sizes. It will depend on where the slicing plane meets the ball. The closer it is to the top edge, the smaller the circle. Once you hit the center, you're going to get the diameter of that sphere, and you're going to have the largest possible circle. Part C says, how will the plane have to meet the ball so that the plane section consists of just one point? Okay, so if you picture the ball and the plane as distinct but being brought toward each other, the plane section of just one point occurs when the plane just makes contact with the ball. As you can see here, this plane is just sitting at the very top of the ball, and you can just see one little dot right there of the ball. That is called, by the way, point of tangency. Point of tangency. Okay, page 2, example 2. The right rectangular prism in figure 4 has been sliced with a plane parallel to the face ABCD. The resulting slice is a rectangular region that is identical to the parallel face. A. Label the vertices of the rectangular region defined by the slice as W, X, Y, Z. So since they're naming it W, X, Y, Z, we want to correspond parts. So A will correspond with W. So if I'm going to label these points, that would be this corner right here, and that's W. And then X corresponds to B. B is here, so X will be right here. And then Y corresponds to C. C is here, so Y would be here. And then finally Z corresponds to D, so Z is right there. To which other face is the slice parallel and identical? Well, if it's a rectangular prism, it's parallel to this front face, and the front face is parallel to the back face, so therefore the slice will be parallel to the back as well. And since we went starting top left, working counterclockwise, I would call the back piece G, H, E, F. Part C says, based on what you know about right rectangular prisms, which face must the slice be perpendicular to? Okay, so by definition, if a slice is perpendicular, the intersecting segment that it creates, okay, let me change to a thinner and green. So perpendicular means it forms a right angle. So if this plane is perpendicular to this base here at this point, or at these points on this line segment ZY, it is also perpendicular to, let me label it right here. Okay, so WX and ZY is where this slice intersects the two sides that it is perpendicular to. So since the slice is parallel to two faces, it would be perpendicular to whichever sides those faces are perpendicular to. So therefore, the slice is perpendicular to faces on the left and right, but it's also perpendicular to the top and bottom. So those are going to be, the left side is that a D? D, C, E, F. It's perpendicular to the left side, which is A, B, H, G. It is perpendicular to the top at this point, on this line right here. So this shaded plane is perpendicular to the surface plane, A, D, F, G. And it is also perpendicular to the base plane, which is B, C, E, H. So it's perpendicular to all four sides that it's not parallel to. Okay, exercise 1 says, discuss the following questions with your group. The right rectangular prism in figure 5 has been sliced with a plane parallel to face LMON. So this is parallel to this side over here, LMON. Okay, LMON. The right rectangular prism has slice with parallel to LMON. Yes, so this shaded region is parallel to this side. A. Label the vertices of the rectangle defined by the slice as RSTU. Okay, so I like to go in order. So L corresponds to R, so this would be R. R's the pirate. L, M corresponds to S. M is here, so this point right here would be S. O corresponds to T. O is here, so T is here. And then finally, U is down right at this corner here on the shaded region. What are the dimensions of the slice? Okay, so if this slice is part of this prism, and we cut through parallel to this face, then it's congruent. This rectangle here is perpendicular, or I'm sorry, congruent to this rectangle, so it has the same dimensions, which is 10 by 11. So 10 centimeters by 11 centimeters. And then finally part C, based on what you know about right rectangular prisms, which faces must the slice be perpendicular to? So it's perpendicular to all the faces except this left side, that's yellow, and this, or right side I should say, that's yellow, and then this left side over here. So it is perpendicular to the top, the front, the bottom, and the back. So let's start with the top. That would be, and it doesn't matter how you name these, as long as when you start at a point, you go around it, you can't cut across. So POMJ is 1. That's the top. It is perpendicular to the top. It's perpendicular to the bottom, QNLK. It is perpendicular to the back, PONQ. And it is perpendicular to the front here, which is JKLM. Okay, and these orders don't matter. You don't have to have POMJ. You could have called it PJMO or OMJP or OPJM, but you can't cut across. You can't say JOMP, something like that. Just go around it, naming them as you go. So if I started at P and went clockwise, P, O, M, J, which is what I have. Okay, page 3. Example 3. The right rectangular prism in figure 6 has been sliced with a plane perpendicular to BCEH. BCEH is the base. So this shaded region is a slice and it is perpendicular to the base. The resulting slice is a rectangular region with a height equal to the height of the prism, which is 6 inches. A. Label the vertices of the rectangle defined by the slice as W, X, Y, Z. So I will call this W. I will call this X. I will call this Y. And I'll call this Z. To which other face is the slice perpendicular? Okay, so now we know it's perpendicular to the bottom right here. If I were to rotate this and look at it, it would form a 90-degree angle with the bottom. It will also form a 90-degree angle with our top. Okay, so that will be ADFG. But it is not perpendicular to the front, the back, the left, or the right. It says, what is the height of the rectangle WXYZ? WXYZ, we were told, is equal to the height of the prism, which is 6 inches. And then it says, Joey looks at WXYZ and thinks that the slice may be a parallelogram that is not a rectangle. Based on what is known about how the slice is made, can he be right and justify your reasoning? Okay, so the slice was made perpendicular to the face BCEH, which is the bottom. Then we know that the angles in the slice, angle X, angle Y, formed by the slicing plane and the face BCEH are right angles. If we focus on angle X, okay, so let's look at that. Angle X, this is a right angle. If we focus on angle X of the slice, since it is a right angle, we know that WX must be perpendicular. WX, this line here, must be perpendicular to A, B, C, D. So it's perpendicular to the face. No, it says BCEH. Yeah, the bottom. It's perpendicular to the bottom. I was going to say that isn't right. Okay, but it is perpendicular to BCEH, which is the bottom, and that's marked. I already marked that right there. WX, this line segment that's formed by the intersection of the vertical plane and the base, lies in face ABCD. Which is perpendicular to both BCEH. Okay, so it's talking about lying in, let me reread that. If we focus on angle X of the slice, it is a right angle. We know that WX must be perpendicular to face BCEH, the bottom, yes. WX lies in face ABCD, which is perpendicular to both BCEH, the bottom, and ADFG, the top. So WX is perpendicular to ABCD. This means that WX must also be perpendicular to WZ. Okay, which means it's perpendicular to this side over here. So this is a right angle right here. A similar argument can be made for angle Y. of the slice, making all four angles of WXYZ right angles and making WXYZ a rectangle. Okay. Hopefully you understood that. Exercise 2 through 6. In the following exercises, the points at which a slicing plane meet the edges of the right rectangular prism have been marked. See these four green dots. Each slice is either parallel or perpendicular to a face of the prism. Use a straight edge to join the points to outline the rectangular region defined by the slice and shade in the rectangular slice, a slice parallel to a face. Okay, so it's a little different for me on this screen. I will choose red, and I will choose not real thin, but thin. So I'm going to try to do this as accurately as possible. All right, so there's my segment connecting those two dots. Here's my segment connecting those two. And there's the top face, and then finally this piece down to here. Okay. Now I'm going to do something that you can't do on paper, and I'm going to group these so they're all one piece. And then I'm going to fill it with orange. Okay, so this might not be closed, so it might not let me fill it. No. Okay, so there it is. Rectangular region defined by a slice that is shaded. So this slice here would be parallel to this end if I called it ABCD. It would be parallel to ABCD. It would also be parallel to, if I called this E, F back here, G, H. It'd be parallel to the left side and the right side, in other words. Okay, page 4, number 3 says to draw a slice perpendicular to a face and shade it in. So I will use blue on this one. Let's see, blue, and maybe that thickness. Try to get my point right on that green dot and up to there. That's better. Over like so, and like this, and then finally from here over to here, and then shade it in. Okay, so there it is, shaded in. A slice perpendicular to a face. Well, what face is it perpendicular to? It would, if I were to label this would be perpendicular to this side here, ABCD. At this point here, forming a 90-degree angle here. Okay, and also over here, if I name this E, F, G, H, the left side, it is perpendicular to that as well. Since it is tilted down, the angle above this would be less than 90 degrees. The angle underneath here would be greater than 90, so it's not perpendicular. Okay, number 4 says to draw a slice perpendicular to a face going through these 4 points. Okay, so I'll do this again. In this case, I will use, oh, I don't know. How about orange? And again, I try to be as accurate as I possibly can. And there is my section. Okay, so there it is shaded in. And this is perpendicular to the top or the bottom. So if I name the top A, B, C, D, or the bottom E, F, G, and down here, actually G, okay. Wow, that is really deceiving. Once you start drawing letters in, it messed it up. So let me do that again. Let me change colors. Sometimes you lose perspective and the thing rotates on you mentally. So if it were perpendicular to the bottom is right here. A, B, back here at C, and down here at D. This rectangle down here is the bottom. The top is E, F, G's up over here, and H is over here. This rectangular top up there, rectangular top. This is perpendicular to the top and the bottom of the box, if you will. Okay, in exercises 5 and 6, the dimensions of the prisms have been provided. Use the dimensions to sketch the slice from each prism and provide the dimensions of each slice. Okay. So we have this slice here that goes from this point here. I forgot to use my straight segment. And let's use green. So I start here and I draw that slice over to there. And that is the same as the width, which is 13 millimeters. Okay, so this is 13 millimeters. And then if I were to draw the same one over here, like so, let me change its color to the same. That's also 13 millimeters because it is the same length as this base and it's parallel. Okay, so then I'm going to draw the next one. And from this point to this point here, and it is the same length as this base right here, which is 20 millimeters. So this is 20 millimeters. And then finally, drawing a straight segment from here to here. And so there is my cutout. And that is also 20. So it's 13 millimeters by 20 millimeters. It is parallel to the bottom and the top. It is perpendicular to all four sides. Okay, page 5, problem number 6. A slice perpendicular to a face, given these 4 dots. Okay, so I've already done this off to the side. And so if I just move this over here like so, there it is. So there's the 4 dots, there's the shaded region. Okay, so if I were to cut that out and rotate it around so we're looking at it straight on, it is a rectangle with a, let's see, I think I'm covering something up. Yes, this was 8 right here. So let's not put that right on top of it. So that's this shaded in, and it's a 6 by 8 by 12 high. So this piece here is 8 wide and 12 high when I cut it out and move it off to the side. Okay, this is page 6, and it is the end of lesson 16. So review a lesson summary and go do your problem set.